Hello, Dr. Sieglum. This is Andrew Lawrence, and this is my self-analysis assignment. I'm revising my original submission into a YouTube playlist, I hope. This is using Screencast-O-Matic, Screener, I think bits of Jing. I'm working with Screencast to see if I can present information this way. So first, I want to show you bits from the table that we were supposed to use as self-analysis. Compared to table 4, now I'm not going to read all this to you, but we'll talk through the big points. Compared to table 4, I rated myself between a 5 and a 6 because I'm pretty comfortable using technology. Some examples are warm-up assignments and agendas and course content that my students can get online from any of their devices. One example I like to use, not sure what my computer was doing. One example I like to use is in physics class when my students take data. We do it in several different ways. Sometimes the entire class collects data together using a Google form and a spreadsheet. This allows us to analyze the data as a class, and we get lots more data points that way. Other times the students' groups use computers by themselves and will do graphical analysis on their data, and then they present this with whiteboards to the rest of the class. Sometimes whiteboards are the best technology tool for the job. They're quick, they're easy to use, and the students do it fast. Working on my technology skills, but I'm not sure I'm a 6 on this scale because of the learning from my students part. I certainly observe things that they do, but I haven't required them to post to a website enough for me to substantially learn from them. I'm trying to fix this. This year I think I'm going to have students post a correct solution to problems we do, such as warm-ups and homework problems, and this will give them a creative opportunity to maybe show me some neat ways to do this. Most kids will probably just scan or take a picture of a solution, but some of them might go above and beyond. Someday I'd like to also make them do some audio explanations with that, like using Screencast or Jing or something like this. In Table 5, I rated myself a 5. I've certainly connected with some other physics teachers. I'm on a listserv with lots of physics teachers like me, and social media like Twitter. We talk mostly about lab setup because it's very physics teacher specific, and I don't have another physics teacher close by, so it's been useful to have input from those kinds of people. I can't call myself a 6 because I don't have the students particularly expanding the curriculum. They might think they do because of the question, answer, and dialogue that happens before a lab activity. This is really just, most of this is really just me trying to feed them the correct lab procedure, but making them think they come up with it on their own, which is sort of best practice. I'm working on that. I like this idea of the students creating quality questions. This made me think that, someday I should have the students making can you make a problem that we'd need to solve, like that I could put on a test or that we could use as a quiz practice. Have the students create those instead of me always creating them. Would put them a little more in charge of expanding the curriculum. As far as using these tools, I have used Jing before, but I'm interested in being able to upload them to YouTube, so I tried using Screener also. It's on my old computer, so the microphone didn't come out very good, but it'll be part of this YouTube. It'll be the next thing on this YouTube playlist. And then while I was waiting on that, I also tried an app for my phone and did another example. Both of these are going to be me talking through solutions to a physics problem the way I might have my students do. And we'll see which one we like best. Thank you, and let me know if there's anything else I need to do.